Good morning, ladies and gentlemen. This is Ben Keyser with Applied Flow Technology, and I would like to thank each and every one of you for attending our webinar today. And I want to let you all know that the webinar is being recorded as usual. If you are listening in live, you'll be sent a link later on this week or early next week. That way you can watch the recorded version again later, or you'll be able to send it around to your colleagues. And then if you're listening in to the recorded version, then thank you for listening in. Anyway, today we're going to talk about the brand new AFT Arrow Automated Network Sizing Add-on Module, ANS for short. And before we get into our topics for today, I want to give a quick rundown on where you can find information about this incredibly powerful tool. One thing is you can go to our website, aft.com, and then under the products menu, this is where you can find information about AFT Fathom, AFT Arrow, AFT Impulse, etc. And if you went to the AFT Arrow page, this is where you can learn more information about AFT Arrow in itself. And if you scroll down to the bottom, there's our add-on modules section for AFT Arrow. There's the goal seeking control module and the automated network sizing module. And this is the one that we're going to be talking about today. So if you were to go in here and click on that link to look at the ANS module page, it's going to first ask you if you are a owner operator or if you work for an EPC firm. And the reason why is because there's just very slightly different messaging for the key benefits that would favor owner operators versus the key benefits that would favor an EPC firm. So you just pick one or the other, and really the content is virtually the same. There's just a couple key benefits that favor one over the other. But I want to make it very clear, the software is exactly the same. The software is not going to do anything differently at all. So just pick one of those for whichever one that you're working in, and you can find more information about how the ANS module will be able to help you. So this is where you can find that information. Before we go forward, I also want to mention that we have a really special deal going on for the introductory price for the ANS modules for AFT Fathom and AFT Arrow. As you can see on our main homepage here, if you were to purchase the ANS module before October 31st, 2019, you'll be able to purchase it for 50% off. So that's an excellent deal. And if you're within the United States, you can go to products and then pricing and how to order, and that's where you can find pricing information. If you are outside the United States, then be sure to contact your local channel partner wherever you are in the world, and they'll be able to help provide you pricing information for the add-on modules. So that's where you can find that information. Now, I've already done a handful of webinars for the AFT Fathom ANS module. Where can you find those webinars? Well, if you go to the Learning Center, under webinars, there's upcoming webinars. This is where you all register for today's webinar. But our webinar library contains all of our recorded webinars that are available for you for free on demand. So you just fill out the form of information, and then for AFT Fathom, this is where you can find various ANS webinars for AFT Fathom. For example, I'm going to point them out for you here. There's how to utilize the automated network sizing module, size your pipes in no time flat, and there's another one that's supposed to be on there, but I'm not seeing it. So what I want to recommend to you all is to go to our YouTube page. So if you scroll all the way down to the bottom of our website, you can click on this YouTube button, and it'll take you right to our YouTube page for Applied Flow Technology. And this is where you can find various playlists and different webinars. And so this is where you'll probably be able to find the other webinars on the ANS module. So that's our AFT YouTube page. You can find a lot of neat stuff and useful pieces of information there. One of the webinars that is really useful for understanding how to use the ANS module is this particular webinar right here. How much will your system cost you? In that webinar, I demonstrated how you can do cost calculations in AFT Fathom, and the same procedures would be able to be done in AFT Arrow. In that webinar, I break down how you would actually go about building a custom cost database for piping and fittings and components. The reason why that's really important is because when you use the automated network sizing module, usually it's best if you can minimize your cost when you're coming up with your designs. And so this webinar will show you in great detail how to build cost databases. And then database management talks about how to use component databases in general. So those are some excellent webinars to make sure that you watch at some point when you have some time. All right, so let me go ahead and move this aside, and I'm going to jump into the model that I'm going to be demonstrating today. This is a very simple air distribution system. We have atmospheric air coming in through that tank, followed by a blower or a fan, which is using the sizing option. So here, when you're using the sizing option, you can specify a fixed flow rate, and then AFT Arrow will calculate the required pressure rise that you need in order to be able to overcome your system resistance and any elevation change, although elevations don't typically make that big of an impact for modeling gases with compressible flow. But it will be taken into account properly though. After the fan, the flow splits off in two different directions. And in one leg, we have a side of the building where we're discharging to 3 different rooms. And then another part of the building, we're discharging to 2 different rooms. Each of those rooms has some control valve junctions modeled. Now, these control valves may not necessarily be modeling real control valves. These could very well be dampers in your system. And what this will help you accomplish is figuring out how wide your dampers need to be open in order to be able to get the flow rates that you want. So what we've done here is we have specified fixed flow rates on all of the control valves in order to get the system flow rates that we want to each delivery room. Now, here's the thing I want to point out really quick. We have a fixed flow rate here, 1250 SCFM, and then we have it broken down 250 standard cubic feet per minute, 250 standard cubic feet per minute, 250, 250, but then this control valve has a fixed pressure drop of 2 psi. Why is that? If I was to set this to be the same 250 standard cubic feet per minute, if I was to try and run this model, it's going to give me a reference pressure message. And what that reference pressure message, I'm sure you all have probably seen it before. If I was to ignore ANS really quick and run it, this is the message that you would see. One of the fundamental things is whenever you see a message that pops up in the software, you should actually read it. The message will give you information about what's going on and why something may or may not solve. And so if you were to go into this message and click on the help menu, that's going to pull up our help file, which goes into detail about a very important topic, which is absolutely critical to understand. This is essentially what we have in our system, where I've fixed the flow rate on the upstream end at the fan, and then I fixed the flow rates at the downstream end for all of the control valves. What that does is it bounds the entire system by fixed flow rates, and it's possible to calculate a pressure drop that will give you the desired flow rate that you want. But the problem is, what's the pressure in the middle of the pipe? Well, what's the pressure at the inlet? What's the pressure at the outlet? It's impossible to figure that out, because just based upon the pressure drop, there are many different unique pressures that can give you the pressure drop you need to drive that flow. That's where you need a reference pressure. So this topic right here, called the role of pressure junctions, talks about that at a simplified level, but I want you all to do a homework assignment and read the detailed discussion. This is really important to understand, because AFT Arrow is not doing magic. It's doing mathematical calculations, the same ones that you'd be doing by hand. And so this is a lengthy topic, which is really important to read, because it's also possible to run into that reference pressure issue when you're using different combinations of fixed flow, assigned flow junctions, or various pressure control valves. So read that topic, and it'll help educate you on when to avoid running into that reference pressure problem. So basically, with the way that I have the system modeled, because I have bounded flow rates with the fan and the control valves, there's no way for the upstream boundary to communicate with the downstream boundaries. They can't talk to each other to determine a unique pressure in the system. So this is why we have to open one of these up. So I'm going to pick this control valve. It looks like it's the furthest remote control valve in the system, and I want to ensure that the most remote control valve is maintaining the minimum pressure drop that I need in order to ensure good controllability of the control valve. So that's why it's set to use a constant pressure drop of 2 psi. The reason why I wanted to go into that is because you're going to see it again later when I start walking you through what the sizing process looks like. So with that being said, I'm going to go ahead and turn on, well, first of all, how do you turn on the automated network sizing module? First, you have to have a license for it. It doesn't require a separate installation. When you install Arrow, it actually installs the ANS module and the GSC module. And if you have a license, you can access them. So the way that you can do it, one way is to click on the button just to the left of the green status light. If you click on that guy, this is one way where you can check the box for the module that you want to use to turn it on. The other way that you can activate the add-on module is by going to the Tools menu, and then under the Tools menu, simply click on Activate Modules, and you can check the box there as well. So when you do this, it turns on the ANS module. Now, the next thing that you would have to do is go to the Analysis menu and actually use the automated network sizing capability. So it could be turned on, but not being used. So after I turn it on, I need to go to Analysis and then click on Automated Network Sizing. And right now, as you can see, it's not currently being used, but then I want to turn on Network. So once you click on Network, you can now use the ANS module capabilities. So what you would do when you build your model is you would define your piping system with your various pieces of input. We have defined some starting pipe diameters, either 3 inches in diameter or 6 inches in diameter. And then we have various lengths of the pipe ducting to each of the various delivery points. And then you can see for the junctions that we have defined the input for all of our various system components, etc., etc. So after you have gone through the process of defining your pipes and junctions, that's simply the same first 3 items in your checklist that you're already used to. The way I pulled that up was by clicking the green status light in the bottom right corner. So these first three items, those are the same thing that you are doing all the time already when you're using AFT Arrow. The only new one is to go through the process of defining your sizing input. That's where you go through the sizing process. So here's what we're going to do. We're going to start off with our first scenario where we're going to minimize the initial cost of our system. So the first step in doing the sizing process is to go to the new sizing panel. This sizing panel right here where the primary windows are is where all the magic happens. So if I click on that sizing panel here, we have a window with a lot of buttons. But the thing is, when you walk through each step by step, it's really easy to go through the sizing process. So here, I've clicked on the sizing panel, and at the bottom of the sizing panel, these are the steps that you need to take. First, you need to define a sizing objective. You know, it's one thing to just size your pipes, but how are you going to size your pipes? Well, not only do you want to make sure that you meet your design requirements, you want to make sure that you actually have a really good design. How do you make sure that you have a really good design? Well, one is by minimizing how much it's going to cost. So if you can minimize how much your system costs and meet your design requirements, that's when you know that you have a really good design. So that's the sizing objective, is how are you going to size your pipes? It's what you're going to try and minimize in order to meet your design requirements. That's the first step. The next step is to set the size and cost assignments. What that option does is that's where you would specify which pipes in your system are going to be allowed to change versus which ones are not. So in this particular model, I want all of my pipes to be sized because this is a brand new system. But let's say that this is an expansion and right here it's not actually atmosphere. Maybe this represents a part of the process that you're expanding onto, and all of this is an expansion here. Well, in that particular case, you may have pipes that are not allowed to change because they're already in the plant. So there are some different sizing options there. Candidate sets, this is where you pick which pipe materials you can use and select from when sizing your pipes. And then design requirements is where you define your design requirements, so on and so forth. So I'm going to step you through each part of the process and break it down one by one. So let's go back to the sizing objective. You do have the ability to define these different panel options out of order. You don't have to go left to right, but the way that it makes the most sense is to go from left to right. So start with your sizing objective, then your cost assignments, candidate sets, design requirements, so on and so forth. But later, if you need to go back and change something, that's where you can do them out of order very easily. Give me just one second here. Excuse me. Okay. So let's break this down piece by piece, starting with the sizing objective window. In the sizing objective window, I have three options: perform sizing, calculate cost, do not size, and then do not size at all. After those three options, the next thing that you would do is you would pick the objective that you want to either minimize or maximize. So if you have actual cost information like material and installation costs for your pipes, your components, your pumps, your fans, your compressors, etc., that's where you would want to consider minimizing your monetary cost. But let's say that you don't have any monetary cost information. Nobody's given you what your pipe material and installation costs are yet as functions of diameter. Well, if you don't have any cost information, well, you can't use cost information then, unless you made it up. You could make it up and guess if you want. but we all know how that works out. So what you would do is use one of these other options that do not relate directly to cost. But one of the best ones is to try and minimize the overall piping weight. If you were to click on that option, it simplifies things dramatically for you. Watch this. I clicked on sizing by the piping weight, and it grayed out all of the stuff down here, and it also removed one of the items that you needed to accomplish in the panel down here below. So this is a very quick and simple way of being able to minimize your piping weight in order to meet your design requirements. It simplifies it when you don't have that additional cost information. It would be the same thing if you were to choose any of the other options like pipe and fluid weight, flow volume, or the inner pipe surface area. So all those are different options. Now, I'm going to come back to monetary cost, and actually I'm going to reload the scenario. Hopefully I didn't accidentally change anything. Let's see, there we go. All right. So currently our objective today in this particular model, I actually do have some cost information. I have material and installation as a function of diameter for the piping, and then I also have some cost information for the fans in the model. So I'm going to minimize the monetary cost. FYI, when you're minimizing monetary costs, there's different ways to do it. You can, there's several options. You can either minimize your initial cost. That's where you only care about making your upfront cost as cheap as possible. All you're trying to do is make that material and installation cost as low as you possibly can. But the thing is, when you have smaller diameter pipes, that's going to increase your frictional pressure drops in the system. And when you have higher frictional pressure losses in your system, your fans and your compressors are going to have to work a lot harder to meet the demands that you want. And so that's going to require higher horsepower from your fans and compressors, and that's going to send your energy costs through the roof. So the thing is, if you only care about minimizing your initial cost, it's going to cost you way more money in the long run. So what's a better option to do is to size by initial cost, but show what the energy costs actually are. This doesn't require any additional steps other than simply defining your energy cost information. So this is 11 cents per kilowatt hour, and I'm running my system for a system life of 5 years. So again, this is still going to make my system be as cheap as possible up front for material and installation based upon what I've selected in this column here, but it will calculate the energy costs for me. That's important because then I'm at least not blind to what those costs are going to be. So it's important to at least be able to know what those are. And then the other options are to size your system by minimizing both your life cycle costs. So not only are you trying to make your material and installation as low cost as possible, but it's really important to account for your life cycle as well. So when you're trying to minimize based upon all these costs, this is what's going to give you the most cost-effective design, especially in the long run. Now we're going to talk about an initial cost limit a little bit later on, so I'll come back to that. Those are the different options that you have for how you're going to minimize the monetary cost of your system in order to meet your various design requirements. That is when you choose this option right here to perform the sizing. When you choose the option to perform your sizing, it's obviously going to change your pipe sizes for you in order to meet these goals of minimizing your monetary costs, as an example. Now, what about the middle option? why in the world would you choose calculate cost, do not size? Well, if I click on that option right here, what this is going to do is it's not going to change pipe sizes for me. Okay, so if I was to choose this option in the middle, it's actually going to use the pipe sizes that I have already defined in each of the pipes here in my model. So those pipe sizes will not change when you use the middle option. Why in the world would you want to do that? Well, let's say that you don't want to size your system. You just want to run your system as it is first, really quick, and you want to know how much does it cost based upon what's already there. Well, if you're designing a brand new system, typically what a lot of people do is they're going to take a previous project that they worked on, and they're going to adapt that to their new system that they're trying to design. And when they adapt it to their new system design, they may not care about changing the pipe size yet. All they care about is trying to meet the design requirements. And once they're able to at least meet the design requirements to get things to work, they would want to be able to calculate what that cost would be based upon that system. After that, that's where they would go through and start figuring out how to optimize things a little bit further. So the middle option is when you want to just run a system and calculate whatever the cost is as it is before you do any pipe size changes. The third option, do not size. This is just like you're running a regular AFT Arrow run. So if I click on do not size, it's not going to do anything. This is basically just like running standard AFT Arrow. Why would you do that? Well, maybe you don't want to go through and delete all of this information here. So checking the box for this option here gives you the flexibility to just do a quick arrow run to see what your regular results are without having to delete any of that ANS sizing data that you might have already specified. Incidentally, if you choose the middle option, this is like doing AFT Arrow with cost calculations. So if you were to open up the example help file, which contains all of our walkthrough tutorials, this help file of tutorials contains 2 examples that show you how Arrow can do cost calculations without the ANS module. Now that's not going to change your pipe size for you. It's just going to tell you how much everything costs. But essentially, if you were to choose that middle option, it's doing the same thing as what those 2 tutorials would be teaching you about. All right, so I'm going to choose perform sizing, and we're going to start off by minimizing our initial cost, but we want our energy costs to be calculated. Now, when you finish each of these steps, you'll see a little green check mark. Once you see a little green check mark, that means that the step that you're currently working in this panel is completed. You can then move on to the others. So now we'll go to size/cost assignments. So this one is where you would go through the process of doing a couple things. First off, what we have here is our pipes, and these are all of the pipes in our piping system. Now, one of the things that allows a lot of flexibility is how you can use dual monitors with the software. You can pull off the panel into another monitor. That way you can see your model and the sizing panel at the same time. But since you're not able to see my other monitor for the webinar, I'm going to dock it to the right-hand side. So here's what's going on before we get into the common size groups. First, we need to go through this area here, and we need to figure out which pipes are going to be sized or not sized. So that's the first thing is, are your pipes going to be sized or not sized? Let's talk about not sizing the pipes really fast here. So if I click on all, I can move them all back to do not include in cost. So here's what this does. If I was to keep all of my pipes with these buttons to not include in the cost, it's going to keep the pipe sizes that is defined for each of the pipes, and those pipe sizes will not change. Also, it wouldn't even calculate how much they cost in the report after I ran my model. So really, this is not doing anything. This is just for, like a regular arrow run. But maybe this is an expansion. Let's say that this flow path here was an existing system, and this area here is the new part. Well, what you would do in that particular case is you can take all of the pipes that are in the existing part and just keep them set to do not include in cost. But then, let me change my pen color here. For the new system, what you might do is select those pipes and move them over to the column to always include them in the sizing and the cost. So these particular pipes here can change their size and it'll calculate the cost for you. All right. Now, I'm not going to go through all the different reasons why you might use various options versus the others, but there's two others right here that I didn't talk about, and there's usefulness for using those options as well, but I'm going to skip that for right now. Change my pen color back to red. There we go. All right. So what I have done is I have set all of my pipes in the model to be allowed to change their pipe size, and Arrow is going to calculate not only what pipe size they need to be, but how much it's also going to cost for each of those pipes. Now, one thing that I want to show you here is the number of independent design variables. So the first step that you would do when you move all these over, initially, if you don't do anything else, each of these individual pipes would then potentially have the ability to have their pipe sizes be changed individually. That means that you could possibly have 18 different pipe sizes all throughout your network, which is perfectly fine. That could give you a really good solid design that truly helps you meet your absolute minimum cost, but it may not be very practical. You might have flow paths that you want to force to be the same size simply for maybe continuity purposes or simplification of making it easier for your purchasers to not have to go and buy a whole bunch of different pipe sizes, because if you leave them to their own devices and they're having to buy 18 different pipe sizes, chances are you're not going to get the pipe sizes that you requested. So that's where you might need to have some pipes being the same size when they're sized, so they'll size them together. Now let me see if I can reload this because I lost all my common size groups. Here's what we'll do is I'll just reopen this. Okay, perfect. So what I did was I went through and I selected various flow paths, and once they're selected on the workspace, we move them over to the common size groups. So what is a common size group? A common size group is a handful of pipes that have to be the same size. So as an example, our discharge piping. Our discharge piping is all of these pipes here and these pipes here. So there's a total of 8 of them. So those 8 pipes are all going to have their size be changed during the sizing process, but they're all going to have the same size in the end. And again, that's for simplification purposes. That way, rather than the purchaser having to go through and get a whole bunch of different sizes, it'll keep them the same. So what we would do here is very easily on your workspace, you would select them on the workspace first, just like that. And then after you've selected them, click on this button here for Workspace. When you click on Workspace, that will select the rows in the table here. The next step would be to click on this button. Well, first, before you do that, what you need to do is you actually need to create the common size group. So the way that you would create the common size group is you would click on this button right here. You would give your new common size group a name, and then it will end up in the list here of common size groups. So after I made my common size group and I've got all my pipes selected from the workspace, the next thing I'm going to do is click on Move To, and this is where you can move these to different common size groups. So if I made a mistake and I put them to compressor piping, whoops, I didn't want to do that. Well, this is very easy to fix it. You just click on Workspace when they're selected, and then you can move them right back to discharge piping. So don't let all of these different buttons intimidate you, because the tools down here, as well as how easy it is to select things on the workspace, that gives you a lot of ease and flexibility towards assigning different pipes to different common size groups very, very quickly. So if I scroll over in this list, there's a total of 4 different common size pipe groups. So all we do here is we just select them on the workspace, click on Workspace, and then move it over to the appropriate group. Now you can also sort these. Right now, these are sorted by pipe in numerical order, but as you can see here, it separates some things, and I don't want to have that separation. So you could reorder things by group. So what this could do is it will sort things by your compressor pipes first, all of your discharge pipes, your room A header, and then followed by your room B header, which is just scrolled over here to the right. So this is really beautiful because when you set up all of these common size pipe groups, this pipe right here is not in a pipe group. That's this pipe right there. So it's okay where not all your pipes have to be in a common size group. That's perfectly fine. This just means that pipe 3 is going to be sized independently all by itself. So it can be whatever size that Arrow calculates, independent of all of this other stuff here. So when you assign the various common size groups, what you're doing is you are reducing the number of independent variables. Okay, if you have more variables in your system that can change, then it gives you more flexibility. However, that just increases the vast number of possible combinations of different pipe sizes that you could encounter in order to size your system. So if you reduce the number of independent variables, then it'll allow a more unique solution during the sizing process. So that's a key thing to remember. The more variables that you have, potentially the longer the runtime it would take to solve that system. All right, so all of this is done for the pipes. There is also some sizing steps that you need to do for your compressors or fans. As you can see, I want my fan to be sized as well. I have material and installation cost information for that fan, so I need to make sure that I select the fan and include it in the cost report and sizing. So not only do you have to set your cost assignments for pipes, you also need to do the same thing for your junctions. Also, in my control valves, there is the possibility where I could include them in the report and sizing, but here I don't have any cost information for my control valves. I don't care about what they are right now, so I'm just not going to bother with including them in the cost. So the key thing is make sure that you click on these other buttons here to be ensured that you get all of your pipes and junctions appropriately set up to have their size be calculated and their cost be calculated. So that's the second step. Third step is candidate sets. What is a candidate set? Well, let's focus on the bottom part first. The bottom section right here is all of your different common size groups and then your pipes that are not intergroup. Well, when the ANS module is trying to figure out a certain pipe size that's needed to meet your design requirements, it has to select from a list of available pipe sizes, okay? And unfortunately, it's not able to just, search through millions of databases magically if you don't put those databases into Arrow first. So you have to specify which pipe materials, nominal sizes, and types are allowed to be used for your selection process. In my model here, for all of the pipes, if I go to the model data window, they are all using steel pipe material. So if I open up one of these rows here, they're using steel material from the drop down, and they're all using standard schedules for the type, as you can see in this column. So when I want each of these pipes to be sized, I would click on New, and this is where you would give your candidate set a new name. After you give your candidate set a name, this is where you would pick the possibilities of pipe materials that are allowed to be used for your sizing process. Maybe you want to only select from standard schedules on steel, and maybe you also want to allow HDPE pipe for SDR11. Well, you'd actually have to create separate candidate sets. But this is where you would go through and pick which ones that you want to select from. So in my particular system here, we're going to use steel pipe and standard schedules. And then if you can sort it in two different ways. The traditional way is to sort it standard. This sorts it by size. So you have a particular size and then all of your different schedules. This is not as useful for the sizing or cost calculation process. It's easier to do things by type first and then size. So this sorts everything by all my different schedules. And then when I expand things, I can see all of the different sizes that are available within that schedule. So if I click on STD for standard and then add it over, this contains all of those different pipe sizes for standard schedules. Now, maybe I don't care about certain sizes. Maybe I want to consider only things between 2 inches and above. Well, what you can do is you can select these various pipe sizes and then delete them from the candidate set. That way it only considers pipes that are within the range from 2 inches in diameter up to 48 inches in diameter. We already did that for the existing candidate set. So once you've built it, this is what it looks like. So here I've named it STD steel 2 inches to 10 inches, and these are the only pipe sizes that are in that range. So I'm only considering pipe sizes from 2 inches up to 10 inches in diameter. After you create your candidate set, you would then assign your specific candidate sets to your various common size groups. So that tells my various common size groups which potential candidate sets I can select from. So that's pretty easy to set up with the candidate sets. That doesn't take too much work there. The next step is to define your design requirements. This is what really helps drive your design for the sizing process. So this is where you would specify various minimums or maximums for changing your pipe sizes throughout your system. You can have as many design requirements as you want, but in our particular scenario here, we only have one design requirement for pipes right here, and that is velocity. We've defined a maximum velocity of 150 feet per second. What this means is when Arrow is trying to change all of the different pipe sizes, it's only if it encounters anywhere in the system a velocity that's higher than 150 feet per second, that would be a design requirement violation. That means that whatever design it's landed on that violates any of your design requirements, that particular combination of sizes will not be considered a feasible design. Now, you can have different design requirements for different pipes and different common size groups. This just happens to be the same design requirement for all design groups in this particular model. In addition, you can have design requirements for fans. Maybe you want to stay within a certain percentage of your best efficiency point, etc. For my control valves, all of them are supplied a fixed flow rate except for one of them. J131, this guy's my fixed pressure drop. Well, I want to make sure that all of my control valves are maintaining good controllability. So I've set a minimum pressure drop requirement of 2 psi. And as you can see, I've checked the boxes to assign that design requirement to each of those control valves, except for the one in the middle. That's because it's already using a fixed pressure drop of 2 psi. So those are the only design requirements that I have. Simply pipe velocity and control valve pressure drop. The last step is to assign your cost databases, and I'm not going to go through all the step-by-step procedures on how to do this. If you watch my previous webinar for Fathom on databases and then watch the webinar on doing cost calculations, that'll show you how you can easily create your own common cost databases for your pipes and your junctions. So what we have here is we have a cost database that we created, and that contains the pipe material and installation cost for my piping. And then we also have a cost database for material and installation for the fans. Now again, I'm not going to show you how you build that information, but I will show you a summary of what it looks like. So how do you find what that information is? Let's say somebody wants to go through and check what costs you're using. Well, if you go to database and then go to your database manager, I'm sorry, not database manager, let's do this again. If I go to my cost database, what I can do is choose the option to open up any available databases. How would it be available? Well, if I already created the cost database and I've connected it to this model, it's available for me to go in and check to see what those values are. So if I click on this, you can see that we have two different cost databases. There's distribution costs for the components, that's my fans, and then we have a cost database for the piping. Let's look at the piping. If I click on select and open it up, this is where you can go through and see every different cost for all of your various sizes. Now, all of that's built in. I'm not going to go through that. I want to show you a summary. So if I go to the summary tab, this contains all of the defined information. So as you can see here, if I expand everything, this is where you can get a quick and good look at what all your various costs are. So for steel piping, 1-inch diameter for standard schedules, My material cost is $3.43 per foot. Installation is $4.50 per foot, or 54 cents. If I scroll all the way down to the bottom for my larger pipe sizes, 20 inches in diameter, that's going to be $169 per foot and $69.5 per foot for installation. You can copy this information by clicking on this button, and you can paste it into a spreadsheet. That way, if you want to prepare it for a checker, you can just paste it right in, and that way they can go through and they can check to make sure all of your cost values are correct. All right, so that's my pipe cost information, and then the same idea, if I click on open available, these are my components. And so I've got my fans or compressors. If I do a summary, here's all the different costs for my compressors. All right. Once you get all that linked up, the very last step is to choose your sizing method. There's different calculation methods for changing your pipe sizes. And this is where it's going to take a little bit of education, not big education, just a little bit of playing around with these different methods, because with the different methods, some of them might give you a slightly different design. Well, if each of them are giving you a different design, which one do you go with? Well, go with the one that has the lowest cost. There's two options. You can size continuously or you can size discretely. Continuous sizing, that would potentially end up with a pipe diameter of 17.3 inches in diameter. Well, you're never going to go and buy a pipe size like that. You want to be able to choose from standard pipe materials. That's where you would need to use discrete sizing. That way the selected size is chosen from a discrete list of pipe sizes. All right, so everything is all set up and ready to go. I'm going to go ahead and run the model now. This doesn't take too particularly long to solve here. It takes just a handful of seconds. What this is doing is it is doing regular AFT Arrow solver procedures to ensure that your pressure, flow, and energy distribution is balancing all throughout your network. Once it finds a converged solution, it will then run the ANS solver to use the selected pipe size and calculate the values to see if they are within your design requirements. If they violate your design requirements, it changes the size and then it keeps going through that process. So it tried essentially 670 different designs in order to land on a final solution here. So let's take a look at this. If we go to the output window, we want to take a look at the cost report. How much does our system cost? Well, if we break it down here, I'm going to reset my panes. The total cost over 5 years is just under $200,000. This breaks everything down on a material and installation level for pipe by pipe or your junctions as well, and it gives you what the total cost would be. It also calculates a non-recurring subtotal, and then for the fans themselves, this is where it's really helpful to include your energy cost. If you look at your total non-recurring subtotal, $70,000. That's how much it costs to buy all of your pipes and all of your equipment. And that's what we're trying to make as cheap as possible for this sizing procedure. But if you look at the energy cost in the long run, in 5 years, that's going to be way more expensive in the long run. So this is where it's important to consider your life cycle cost for the sizing process. So let me switch to one of the different scenarios here. Let's look at the life cycle cost here. So $200,000, was our total cost for minimizing by initial, and 128,000 that was energy cost. In this particular scenario, the only thing that I need to change is to use this option. Right now, all of my panels are locked down. I can't make any changes. It does that after you run your model. So I can click on this button right here to unlock them. That way I can make changes. So I don't have to change anything in any of these panels themselves. The only thing that I need to make a change is to size for initial and recurring cost. So this is going to consider life cycle cost for your overall cost operation. So now with that change, let's go and run this and see what our costs are. Again, it doesn't take too long, and imagine trying to change all of those pipe sizes individually by yourself. Trying to figure out the right combination to meet your design requirements will just be very, very painful. Let the ANS capabilities do it itself. Okay, so here's our cost report. Look at this. With our minimizing of our life cycle cost, we were able to reduce the cost from $198,000 down to $166,000. That's amazing. That's a huge amount of savings right there. But it comes at a cost of requiring more expensive pipe material and installation up front. So if we go back to the previous scenario, I'm going to dock this again. Let's take a look at the initial cost here. So for minimizing my initial cost, I'm at $70,000, but I'm paying $200,000 in the long run. If I go to my life cycle cost scenario, what this tells me is if I pay $92,000 up front, I only end up paying a total of $166,000 in the long run. So that's roughly, $20,000 to $30,000 of savings there. Not the greatest at doing math in my head, but anyway, you can see that you have a significant amount of savings in the long run if you are willing to pay a little bit more up front. Now let's take a look at what the resulting sizes themselves were. If I go back to my initial cost, now we know what the costs are. Well, what's the size? If I look at my pipes tab, there's the sizing tab right here, and this tells me what the resulting pipe sizes need to be. Well, what's the original pipe size? Let's go ahead and add that in there. So if I go to the output control window right here, I can click on pipe sizing, and I'm going to add in the original pipe nominal size, and I'm going to move that up. There we go. So initially, my first design was only using 3-inch and 6-inch diameters. After it went through the sizing process, these are the diameters that it came up with that I need for my system in order to get those costs from minimizing initial costs. And then we want to also check our design requirements. So if I check my design requirements, we can see that we don't have any violations in velocity. All of our velocities are less than 150 feet per second. Now, why are these values blue? Well, if we were to go to the sizing tab and then go to sizing method, when you do your sizing process, even if you choose discrete sizing, it's still going to do a continuous sizing first anyway. The reason why it does that is because it just wants to go through and calculate hydraulic diameters that could work for your system before it does the discrete sizing. That gives it a better starting point for doing the discrete sizing process. So the reason why those design requirements were blue in the output window here is because the design requirements for these particular pipes drove the design in calculating a certain pipe size for the continuous sizing process. After the continuous sizing process was done and it was able to go in and figure out the discrete sizing, well, these discrete sizes were able to meet our design requirements very well to where it just, the design requirements didn't really matter. This just gave us the best, lowest possible cost, and these were the sizes that resulted. And simply by using those sizes, the velocities did not get close to those design requirements anyway. That's why it's blue. And then we can see for our control valves which ones have the lowest and highest pressure drops. Now let's take a look at the results for the life cycle cost. So I had between 2 inches and 6 inches in diameter for the sizing. Look at this. For the life cycle cost, in order to get better savings in the long run, it's going to use larger diameter pipes. That's why it costs more up front, but it's going to be a lot more cost effective for you in the long run. And as we can see, we met all of our design requirements for the control valves, and we met all of our design requirements for the pipe velocities. One more scenario that I'm going to do for you. It doesn't take long. Just hang in there with me. This is where I would tell you, hey, if you paid $90,000 or whatever it was, you can save $30,000 in the long run and take your $200,000 cost down to $166,000. Well, the problem is up front, you don't have $90,000. Maybe you only have $70,000 or $80,000 to buy your initial system. This is where you would use the initial cost limit. So right here, I'm still sizing based upon initial and life cycle cost with considering energy, but I have turned on this option right here to do an initial cost limit. So this is where you would put in your initial budget. The initial budget right here is only $82,500. That's the most amount of money that you could spend up front for your system. So this will give you the best of both worlds. It will ensure that your initial costs stay below that limit, but then it'll give you a little bit better of a design to see if it can give you some better savings in the long run. So let's see what this looks like. I think I already have output. I do, but where are my tabs? Let's try this again. So again, this is considering the best of both worlds, the best upfront cost and the best life cycle cost. I must have clicked something that messed something up. But let's take a look at what's going on here. Right now, it hit an iteration where it calculated the best cost was $195,000 total. So it's trying to change the pipe sizes further to see if we can do better than that by still meeting all of our design requirements and still staying within our initial cost limit. I think, there we go. All right, so let's take a look at the cost report. $191,000. Okay, so based upon the initial cost scenario, that was $198,000, and my initial pipes or my initial material and installation costs were like about $68,000. So it's costing me a lot of money in the long run. But then when we put in that initial cost limit of $82,500, these are the actual non-recurring subtotals, and we're still able to save about $7,000. So that's not too bad. Now, the thing to consider here, this is a really small, teeny little system. When you have larger piping networks for a plant or a really long pipeline, those cost savings are going to be much, much more pronounced and significant. Let's take a look at what the resulting pipe sizes are. As we can see here, we have a different mix of a couple larger diameter pipes and then some small to medium sized diameter pipes. And that's what gives us the best of both worlds. It stays under our initial budget, and then it gives us the best design to still save some money in the long run on those energy costs. And that's what the AFT Arrow ANS module does. If any of you have any questions, don't hesitate to contact us. You can contact us on our website, aft.com, under contact. If you have any sales related questions, you can fill out this form and send them to sales@aft.com. If you have tech support questions, you can go to our support center or email support@aft.com. If anybody wants to try out the new ANS module, feel free to contact us, and we'll be happy to set you up with an evaluation license. That way you can try out the capabilities for yourself. Thank you all very much for your time today. Take care and have a great rest of your week.